For decades, downloading the human mind was the stuff of science fiction. Today, it has become an active scientific pursuit with a clear technical roadmap. Ray Kurzweil predicts that human intelligence will expand 1,000,000-fold by the year 2045 through our integration with machines. The ultimate objective is whole brain emulation. This process requires simulating a brain's physical architecture, a task far more complex than copying a digital file to a hard drive. To replicate the mind, we have to account for 86 billion neurons. This microscopic view reveals the staggering physical density and the complex branching dendrites that form the biological brain. Scientists must map the connectome, the complete web of all neural pathways, and translate those organic connections into precise digital models. Mapping the connectome requires crossing a minefield of both biology and philosophy, as the physical structures we're tracing define the self. Executing a 3-step blueprint for brain emulation is the only way to move from biological life to a digital reconstruction. Step 1 is data acquisition. Because the brain is a dynamic system, we cannot rely on a static snapshot. We must map its structural core in real time while it is active. Extraction tools like these EEG caps allow researchers to monitor brain activity. The BrainGenX platform then uses that data to generate realistic populations of neurons and their synaptic sites. Step 2 is the substrate. Standard data center server cabinets represent the current limits of silicon computing, which reaches a bottleneck when faced with the fluid complexity of human thought. A hardware breakthrough from the Indian Institute of Science addresses this limit. Researchers there have developed shape-shifting molecular devices using ruthenium complexes. These molecules physically reorganize their electrons and ions to suit the task at hand. A single device can function as memory, logic, and a learning element simultaneously. Intelligence is physically encoded into the material of this hardware. This hardware provides a digital vessel for the mind, but it does not resolve the complications of moving the original passenger. Step 3 is the transfer. The procedure now moves into the territory of biological identity and digital persistence. The first method is destructive scan and copy. The biological brain is mapped and then destroyed while a digital copy boots up in its place. This creates the philosophical zombie dilemma. A digital copy might lack subjective experience while appearing human, leaving us to wonder if there is anyone actually inside. The second method is gradual replacement. Biological neurons are swapped for synthetic hardware over time. This involves the Sorites paradox. At what point does a human become a machine? We cannot be certain if your first-person perspective survives, or if a machine replaces you. Current methods offer no guarantee of survival. They only ensure that a perfect digital replica will wake up believing it is you. Our lack of a definitive understanding of consciousness is a more significant obstacle to mind uploading than limited computing power. Even if an upload functions perfectly, we may never know if it feels emotions, or if it is just executing an incredibly complex simulation. A successful upload will force a societal shift, requiring us to establish moral status and fundamental rights for digital entities. This quest may result in a new species carrying stolen human memories, rather than a method for cheating death. Hit the like button and subscribe if you want to see more, and let us know what scientific topics we should cover next in the comments. Today's video was brought to you by Synestic Systems LLC, founded by Shane Persinger.